we have an area down here somewhere in the XY plane. And above this we have our usual friend, the truncated rectangular parallel pipe head, right? Okay? And here we have a normal vector that I'll designate by n. And of course, if I know the dimensions of this thing, I could calculate this vector, right? And this vector very easily. So this vector is v1, this vector is v2, and their n vector is just v1 cross v2, right? Now, if you want a unit normal, you could divide this by its magnitude and you get a unit vector, right? And we know that from linear algebra and everything else that you brought into this course, okay? We don't need a unit normal, but it's convenient to use it because then you've already got the magnitude worked out and you never have to divide by it to find a cosine, okay? So what I'm wanting to say then is that this thing has an area S, okay? And A over S equals cosine theta, where theta is the angle between your normal and your K vector. Okay? So there's your normal. Here's K. And here's theta. And this is easily calculated if you know the normal vector. Okay? And of course, n is equally calculated if you know the dimensions of this thing, right? So if your altitudes are defined by some function f of x, y, right? And the rectangle dimensions are all small enough
Wouldn't your function have x, y, and z?
again.
Wouldn't your function have x, y, and z
No.
for the altitudes?
Z is f of x, y, and that's the way you've done it when I said, okay, you evaluate this function and it gives you your altitudes, right? It was just a function of x and y.
Okay.
Now you can confuse that because we've already talked about a density function that's a function of x, y, and z, right? I'll generally use rho or something for the density function just to help you keep that straight because I know that can be confusing, okay? So this is the context of an earlier question. You've got the later question about density and mass in your head. So it's real easy to see one when you're looking at the other. So I should have written it that way, okay? And I'm going to say A over S is close to the ratio of the area in the plane to the actual area of the surface. Which is the graph of f of xy.